Hello, am I audible? Good morning, am I audible? Yes, okay, very good, very good. Good morning, everyone. Good morning. I am audible to everyone. Everyone, am I audible? Okay, good morning, good morning, good morning, good morning. Yeah, just give me 1 minute. Give me 1 minute. Am I audible? Am I visible, audible? Everyone, good morning, good morning. Good morning, Durga. Good morning, Ritvika. Good morning, Saiti. Good morning, Kavita. Good morning, Presi. Good morning, everyone. Very good, very good. Yes. Okay. So, what we were covering in the previous class, we were discussing about vectors. We were discussing about vectors. Yes, some property of cross product is still left. I think I have covered 9 properties and 10th number property. We will cover the 10th number property. Write down the 10th property of vectors. Cross product. 10th property of cross. How was vector cross product defined? A cross B. Yes, it is defined as magnitude of A, magnitude of B, sine theta. This gives you magnitude of cross product. Magnitude of A, magnitude of B, sine theta. This gives you magnitude of product into n cap. This gives you direction. This is the direction of cross product, and this is magnitude of cross product. So if we want to find the direction only, then n cap is to be determined. And if you want to find magnitude only, AB sine theta. This is the magnitude of cross product. Now I will use this concept. I will use this concept for a very special thing. See, we have covered basic mathematics. We have seen what is the area of a parallelogram in basic mathematics. I have covered area of parallelogram in basic mathematics. Suppose this is a parallelogram created by two vectors. This is a parallelogram created by two vectors. Length of this side, I know this is, let's say, A. Length of this side, let's say it is B. Angle between the two vectors is theta. Angle between the two vectors is theta. So, do we know what is area of parallelogram? I have covered this point in basic mathematics. Do you know what is the area of parallelogram? Do we know what is the area of parallelogram? We have covered, I think, in basic mathematics, we know what is area of parallelogram. Area of parallelogram. We have covered this in basic mathematics. Any reply? What is area of parallelogram? Area of parallelogram. Yes, Blissy is giving me correct answer. And Kavita, no, that is wrong. Area of parallelogram. I am asking area of parallelogram, not trapezium. Some are giving me area of trapezium. So I am not asking area of trapezium. I am asking area of parallelogram. If the side lengths of parallelogram are A and B, side lengths are A and B, then this area is given by AB sine theta. Area of parallelogram is given by AB sine theta. We have derived this. The base length here is A, and if you find the height, it is B sine theta. If you find the height, it is B sine theta. So base into height, this will give you area. So area will be base into height, that is A into B sine theta. This is area of parallelogram. Now just see, what is the magnitude of cross product? It is same. So it means the magnitude of cross product gives you area of parallelogram. Magnitude of cross product gives you area of parallelogram. This is the application of cross product. 10th number property we are discussing. We can find area of parallelogram if its sides are given like vectors. We can find area of parallelogram by magnitude of A cross B. Note it down. We can find area of parallelogram. So area of parallelogram whose sides are A vector and B vector. We can find that area by magnitude of cross product of A and B. Simple formula. We can use cross product to find area of parallelogram. Is this clear? Is this clear? Everyone is getting this? Ardhamenda? Everyone? Tell me. Area of parallelogram? Clear. Very good. Very good. Okay. But sometime they will ask you area of triangle. Area of triangle. If A vector and B vector are creating two sides of a triangle, A vector and B vector are creating two sides of a triangle. The third side is not known. A vector and B vector are two sides of triangle, Then if you want to find this area of triangle, how to find it? How to find this? Area of triangle. See, this is nothing but half of the parallelogram. If you complete the parallelogram, this is half of the parallelogram. So just half of the area. Area of triangle will be half magnitude of A cross B. If A and B represents two sides of triangle, then area of parallelogram is half magnitude of A cross B. So if A vector and B vector are two sides of parallelogram, two sides of triangle, if A and B are two sides of triangle, then area of triangle is half A cross B. Half A cross B. So this is the second application, second property in area. 10th number property we are discussing in 10th. The first point was area of parallelogram. Now area of triangle. Okay. But if we come back to parallelogram, suppose this is our parallelogram. We want to find its area. But they are giving us diagonal. If the diagonal of parallelogram is, let's say, P and Q. Diagonal of parallelogram is P and Q. Diagonal of parallelogram is P and Q. And if you want to find area of parallelogram with the help of diagonal, if P vector and Q vector are diagonal of parallelogram, then the area of parallelogram in this situation is given by half magnitude of cross product of diagonal. Half magnitude of cross product of diagonal. Half magnitude of cross product of diagonal. Okay. If PQ are diagonal, then area is half P cross Q. If AB are the side vectors, suppose the side vectors are also given. This is A, this is B. The same area is nothing but magnitude of A cross B. In terms of diagonal, this is half of cross product of diagonal. In terms of side, it is magnitude of cross products of sides. Note this. Note this property. Note this property. Okay, so we have covered what is the area of parallelogram if the side vectors are given, what is the area of parallelogram if the diagonal vectors are given, and what is the area of triangle if the side vectors are given. Okay, now sometime they will give you position vector of points of the corners of the triangle, position vector of the points. Okay, so with help of position, we have covered position vector. Position vector of a point. Position vector. Let us write down position vector again. Position vector of a point. I think we have covered the position vector, but let us redo it. If there is a point in XYZ plane, XYZ space, which is x, y, z. The position vector of point x, y, z is given by xi plus yj plus zk. This is a vector from origin to the point. This is a vector from origin to a point. This is a vector from origin to a point. From origin to a point x, y, z, vector is xi plus yj plus zk. But if you want to find vector connecting two points, there are 2 points. Another point is x2, y2, z2, and first point is x1, y1, z1. I want a vector connecting these 2 points. I want a vector connecting these 2 points. Then this vector, we can write this vector as x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. I can write a vector which is connecting 2 points. You will need this concept in displacement. They will give you initial point and final point. They will ask you what is the displacement. So this is the thing about displacement vector. Final x minus initial x into I, final y minus initial y into j, final z minus initial z into k. This is a vector connecting 2 points x1, y1, z1 and x2, y2, z2. Why we need this? Sometime they will use vertices of triangle and they will ask you what is the area of triangle. So please note this. I will give you a question then. Please note this. I will give you a question on this concept. Please note this. We will solve a question on this concept. Find area of triangle having vertices S A, 0, 0, 0, B, 0 and 0, 0, C. These are 3 vertices of the triangle. This is, let's say, A vertex, this is B, this is C. These are 3 coordinates, 3 points of vertex of triangle. Find the area of this triangle. Try to find the area of this triangle. Find area of triangle created by this vertex. Find area of triangle created by this vertex. We can find area of triangle if we know its side length vector. If you know 2 vectors creating the sides of triangle, we can find its area. But in this question, I am giving you coordinates of the vertex. Find the area. If you observe these points, the points are given in x, y and z axis. A0, 0 is going to be on x axis. 0B0 is going to be on y axis. And 00C is on z axis. So these are the 3 vertices of the triangle. I want area of this triangle created by this vertex. So I want area of the triangle created by these points. If you connect these 3 points, you are getting a triangle. Find me area of this triangle. Find me area of this triangle. Give me this area. Give me this area. Give the area created by these points. Triangle created by these points. Just use the concept of displacement vector. Vector connecting 2 points. You can find out 2 side vectors of this triangle. You can find out 2 vectors of sides of this triangle. If you want to find side vectors, you can find these 2 vectors. If you find this, if you can find this vector, then area will be half of magnitude of cross of this. Vector from this point to this point. Vector from starting point to end point. This vector, let's say this is our x vector, or let's say this is our p vector. This is our q vector. How to write this p vector? Coordinate of final point minus coordinate of initial point into I cap, j cap, k cap. So p vector in this figure is going to be 0 minus 0 I cap, then 0 minus b j cap, c minus 0 k cap. This is going to be my p vector. This p vector is going to be 0 minus 0 I cap, 0 minus b j cap, c minus 0 k cap. So we are writing the two sides vectors of the triangle, and the second vector will be a minus 0. Second vector may be a minus 0 I cap, 0 minus b j cap, 0 minus b j cap, then 0 minus 0 k cap, 0 minus 0 k cap, so 0 k cap. This is going to be p vector and q vector, which are two sides of the triangle. If you know two sides of triangle, we can find the area of triangle. If we know two sides of triangle, we can know the area of triangle. Now area, it will be half magnitude of p cross q. First find p cross q, then find the area. So p cross q, this will be equal to, we can use the determinant method to find the cross product ijk. What are the component of first? 0 minus b c. 0 minus b c. What are the component of second? A minus b and 0. Now just find the cross product. Okay, I will be multiplied with minus b, sorry, this is 0 plus bc. So you will get bci j ac minus 0. So acj, a k will be 0 plus ab, abk. This is the cross product of p cross q. I time 0 minus of minus bc, j time ac minus 0, k time 0 minus or minus ab. This is a cross b. If you know a cross b, if you know the cross product of the side length, then you can find the area. So area will be half of magnitude of this. Area will be half of magnitude of p cross q. Now just find magnitude of this. So magnitude will be root over x component square plus y component square plus z component square. Just write this. This is our area. This is the area of the triangle which I was showing you. It is half of root over a square b square plus b square c square plus c square a square. This is going to be our answer. Tell me, is this point clear? We are calculating area of triangle. So I have taken a little bit difficult question, but we can easily solve the question if you know all the concepts correctly. Okay, how to find a vector connecting 2 points? If you know this concept of displacement vector and the formula for area, so we can easily solve this question. In this question, corner points of triangles were given. Corner point of triangle was given. So I have calculated two side vectors of the triangle. This p vector will be difference of coordinate into ijk. This q vector is difference of coordinate into ijk. So p and q I can calculate, and using that we can find the area. Using that we can find the area. Area will be half p cross q. So tell me, is this question 100% clear? Or if you have any doubt, you can ask me again. Please see this. Please see the solution. Durga Prasad got it. Very good, Durga. Others? Are you getting this question or not? Are you able to understand this? We are finding the area of triangle created by points. Okay, Ritvika, very good. Zamir, very good. Srinivas, very good. Very good. Okay. So in this question, we have learned new things. We have covered the formula of area of triangle created by two vectors, and we have also understood the concept of vectors connecting 2 points. Vectors connecting 2 points, and that concepts are useful. Okay, you will use this concept of area in flux. When you want to calculate flux, then this kind of question may come. And in displacement in kinematics, you will need this kind of concept: how to find displacement vector between 2 points. Okay, so we have covered some of the concepts of the vectors which were not covered in the previous class. I will give you one more question. One more question. Find area of parallelogram created by vectors 3i and I plus j plus k. Find area of parallelogram which is created by vectors 3i and I plus j plus k. Find this area. These two vectors are creating a parallelogram. Find the area of this parallelogram. Solve this. How to find area of parallelogram? Parallelogram, if the sides are given, parallelogram area is a magnitude of A cross B. Sides are given, just find the magnitude of A cross B. Solve this. Solve for area of parallelogram. Give me the area of parallelogram created by these two vectors. You just need to use the formula. We have discussed the formula of area. Just use that formula. Very good. Srinivas, magnitude. Where is magnitude? Durga, very good. Durga, I think there is some mistake. Please check again. Storm, again magnitude. You are not giving magnitude. Area, I am asking area. So you will give me magnitude. Area of parallelogram is magnitude of A cross B. Okay. So let us first find cross product. Cross product of the two given vector I, J, K. The first vector is 3, 0, 0. First vector is only 3i, so it will be 3, 0, 0. Second vector is I plus J plus K, so 1, 1, 1. All components are 1. Very good. Many people are giving you correct answer. Kavya, Durga, now your answer correct. Very good, Rakesh. Very good. So find this vector. I into 0 minus 0, 0i. J into 0 minus 3, minus 3k. K into 3 minus 0, 3k. This is our cross product. This is now you need to find magnitude. This implies that area will be magnitude. What will be magnitude of this? 0 square plus 3 square plus 3 square. Root over 0 square plus 3 square plus 3 square. 3 square plus 3 square, 18. Root 18, or 18 is 9 into 2. 18 is 9 into 2. So root 9 will be 3. This is 3 root 2. Root 18 or 3 root 2. This is your answer. Root 18 or 3 root 2. Jyoti, slight mistake. 3 root 2. Kavya, again you are also doing the same mistake. Okay. This is 3 root 2. 18 is 9 into 2. 9 into 2. Root 9 will be 3. So answer will be 3 root 2. Answer will be 3 root 2. Very good. Very good. You are getting correct answers. Very good. Bahut badhiya. Shabash. Very good. Yes. We don't need to divide by 2. We are asking area of parallelogram. Area of parallelogram is just magnitude of A cross B. If I ask you area of triangle, then you will need to divide by 2. Okay. We are not finding area of triangle. We are finding area of parallelogram. Formula for parallelogram is mod of A cross B. Okay. And if I was giving you diagonal, then you need to divide by 2. These are not diagonals. I am not saying this is diagonal. Devesh, is this clear? Sorry, Dwarkadish, is this clear? Yes. Okay. Okay. So now we know how to find the area of different figures. We know how to find area of parallelogram, how to find area of triangle using vectors. Okay. So our vectors is now completed. Solve all the questions of your gym material. If you have your gym material with you, solve all the questions. Okay. And take your material if they are not with you. Now we will start our new topic. Units and dimensions. We'll start new topic. Unit and dimensions. Units and dimension. In this topic, we will learn about, first we will learn about physical quantity. These are two different things, units and dimension, but they are very related. So that's why usually they are taught in same topic. We will first learn about physical quantity. Physical quantity. Sir, what about river boat? Better that will be taken care by kinematics, na? That is in kinematics. We are covering vector. In vector, we are learning only this. In kinematics, you will use vectors to solve those kind of problem. Okay? Okay, so now we are starting units. What is we are first starting physical quantity. What is a physical quantity? In physical world around us, you see we are living in a world. In this world, we are every time measuring some quantities. Suppose I want to find the length of this pen. I ask you what is the length of pen. Then you will measure with some scale. You will find the length of this pen by measuring with scale. If you are able to measure the length, you are giving me a value with units. This kind of quantity which has magnitude, which has value, they are called physical quantity. A physical quantity has some magnitude, they are measurable. So write down or you can note down physical quantities having some measurement. They are measurable, they are called physical quantity. And there are some physical quantities around us which are not measurable, so they are not called physical quantity. Like color is a property of material property. Like what color I am wearing today? I am wearing a white color shirt. What color of pen is this? This is black color. Color is not a quantity which you can quantify. You cannot assign a number to color. So this kind of quantity are not called physical quantity. Physical quantities are those which can be quantified. They can be measured. They can be also measured. We can define numbers to color. Let's say we are defining 1 to 7 number to 7 Vibgyor color. But then we are not able to measure them now. So these are not physical quantities. Physical quantities are those which can be measured. Physical quantities are those which can be measured. And measurements involve units. Whenever you measure something, you need some kind of unit. How will you measure it? Suppose I ask you what is the height of anyone. So you will give me reading in terms of units also. If someone says my height is 5.8 feet, so they are giving me unit also. If someone saying my height is 170 centimeter, so that is again with unit. So every measurement involves some units. Some exceptions are also there, but generally all measurements involve some units. That's why physical quantities have some units of measurement. And in these units, we are measuring the physical quantity. So what are physical quantity? Which can be measured. And we can classify physical quantities in many ways. There are many ways of classification of physical quantity. Based on direction, they can be scalar, they can be vectors, or they can be tensor. Only scalar and vector are predominantly in our syllabus. We will not talk about scalar tensor much in our syllabus. Only scalar and vector quantities are used in our syllabus. What are scalar and vectors? Scalars don't have direction, only magnitude. We have covered vectors, so we all know what is scalar. Scalar is having only magnitude. Vectors have magnitude and direction. And tensor are a tricky quantity. Okay, they have all the directions. They are present in all the directions. So they are usually denoted in terms of matrix. So they have all the directions. Okay. Vector which don't have directions tensor. Yeah, you can say that vector which don't have direction or vector which is present in all the directions. That is scalar. That is tensor. Some examples are moment of inertia. Moment of inertia is defined for everybody is defined along every axis. It can be defined for every axis. X axis, Y axis, Z axis, we can define moment of inertia. So it is present in all the direction. Okay. So that kind of quantities are called tensor. Stress, strain, these are tensor. We'll learn about them. Okay. But not very much. They are not involved in our syllabus. Okay. So based on direction, this is the classification. Now based on unit, we also have a classification. Based on dependency. Some physical quantities are not dependent on other. Some physical quantities are not dependent on other. They are called fundamental or base. Some physical quantities are not dependent on other. Those are called fundamental or the base physical quantity. And some are dependent on this fundamental quantity. They are called derived. Derived. What are derived physical quantities? Which are dependent on fundamental. If you know fundamental, then you can define derived quantity. Example of derived are like speed. Speed is distance upon time. If you define distance, if you define time, you can define speed. But distance and time, these are fundamental. You cannot define time in terms of other. Okay, so they are fundamental. So there are many examples. Some examples: time, distance, and derived quantity example may be speed, acceleration, force, etc. Okay, so physical quantity based on dependency, they are fundamental physical quantities or derived physical quantity. In SI system, I will talk about SI later on. So these are dependency based on dependency we have defined. Okay, yes, in SI system there are 7 fundamental. Now we will talk about based on units. There are maximum physical quantities have units. Maximum physical quantities have unit. So a lot of physical quantities have unit, but there are some physical quantity which do not have any unit. They are called unitless. They can be measured. They can be measured, but they are unitless. There is no unit involved. Some examples like refractive index. Refractive index of glass, refractive index of any material, mu, or sometimes they represent refractive index by n. So this refractive index is a unitless physical quantity. There are many more examples. Unitless physical quantity. Coefficient of restitution. Coefficient of restitution. This is again a unitless physical quantity. Then coefficient of friction. This is a unitless quantity. Coefficient of friction. Some physical quantities have unit. These are unitless. Coefficient of friction. Then velocity, displacement gradient. This is strain. Strain is also unitless. So there are many examples of unitless quantities around us. Many examples of unitless quantities. So almost all the physical quantity have unit. Some of them are not having unit. They are called unitless physical quantity. Okay. So based on unit, physical quantities are of two types: having unit and not having unit. Okay. Now we will learn about dimensions afterward. But based on dimensions, there are two types of physical quantity: having dimensions and then dimensionless. Those who do not have dimensions, they are called dimensionless. The physical quantity which do not have dimensions are dimensionless. All these are dimensionless. The unitless quantities I mentioned here, all these are dimensionless. They are also dimensionless. There is one special quantity which is dimensionless but not unitless: angle and solid angle. They are dimensionless but have unit. They are dimensionless but have unit. They are not unitless. So a question is usually asked: a physical quantity having dimension should have a unit? Yes. Every physical quantity having dimension have a unit. A physical quantity having a unit should have dimension? No. Angle is example. It has unit but it does not have dimension. This is an example of quantity with unit but without dimension. And all the dimensionless quantities are also unitless. All the dimensionless quantities, unitless quantities are dimensionless. Unitless, it means dimensionless. But dimensionless does not mean unitless. Clear? Unitless physical quantity is also dimensionless. But a dimensionless quantity, dimensionless physical quantity is not necessarily unitless. There are many examples of dimensionless quantity which are unitless, but there is an example angle which is dimensionless but has units. Is this point clear? We are discussing about classification of physical quantities. Okay, so we have classified physical quantities in many ways. Okay, classification based on direction, they are scalar, vector, tensor. Based on direction, there are three: scalar, vector, tensor. Based on dependency, we have fundamental physical quantity, time, mass, length. All these are fundamental. Amount of substance, mole, temperature, current. These are fundamental physical quantity. Then there are derived physical quantity: speed, acceleration, velocity, etc. These are derived physical quantity. Then based on units, there are some physical quantity which have unit. Most of the physical quantity have unit, but there are some physical quantity which do not have unit. They are unitless. What is fundamental and derived? I will come to this point. Fundamental physical quantities are not derivable from other quantity. Okay, they are fundamental. I will come to this point. Wait. Based on units, there are two types of physical quantity: unitless and having unit. And based on dimensions, we have again two types of physical quantity: having dimension and do not having dimension. They are called dimensionless. A unitless quantity is always dimensionless, but a dimensionless quantity may not necessarily unitless. Okay, now we'll come to fundamental physical quantity. Fundamental physical quantity. When physics or science was evolved, we were defining new physical quantities, and in some cases we have observed that physical quantity can be defined in terms of others. If I know others, I can define this physical quantity. Like for example, speed. Speed is defined in terms of distance traveled and time. So if you know distance and time, if you know units of these two physical quantity, you will know unit of distance. So this kind of physical quantity which are dependent on others, they are called derived. But there are some physical quantity which are not dependent on others, like amount of substance, mole, or current, or temperature. Temperature is not dependent on other. You cannot define temperature in terms of mass, length, time, etc. So temperature is a different physical quantity. That physical quantity is called fundamental, which cannot be dependent, which cannot be defined in terms of other. They cannot be defined in terms of other. They are fundamental, and we have taken 7 physical quantities as fundamental physical quantity in SI system. Now let us talk about SI system. Before SI system, just wait. Fundamental physical quantities are this. Now we'll talk about units. Till now, I have discussed what is a physical quantity, what types of physical quantities are there. Now we'll talk about unit. What are units? To measure physical quantity, we need some kind of basis how we can measure the physical quantity. For example, in our childhood, we usually wanted to measure the length of, if we are playing cricket, we usually wanted to measure the length of the field, length of the, let's say, pitch, how long pitch should be. So usually you walk around and you will say that I will take pitch length to be 10 feet. 10 feet. You will walk, then 1, 2, 3, 10 steps should be the fit length. Or crease length. You are putting stumps and you are putting a crease line. Usually crease line is made 1.5 bit at 1.5 bit. You take the length of the bit, you put 1.5 bit length. That is crease length. Okay. So you are measuring distances in terms of bit length or in terms of the walking distance. So actually you are taking reference of something. Actually, you are taking reference of something. So these references, they are called unit. And with comparison to reference, you are making measurement. Units are reference or the basis in terms of which you measure a physical quantity. Right? You can write it down. Units are reference or basis in terms of which we measure physical quantity. Units are reference or basis in terms of which we measure physical quantity. We have defined units of physical quantities, and when we want to measure a physical quantity, we compare the physical quantity with its unit. Every measurement is involved comparison of physical quantity with unit. You can write this. Every measurement of physical quantity involves comparison of physical quantity with its unit. Every measurement of physical quantity involves comparison of physical quantity with its unit. So what are units? Units are the fundamental or reference amounts which you have decided to measure the physical quantity in terms of these units. Okay, there may be different types of units for same physical quantity. There may be different types of units for same physical quantity. For example, length can be measured in some meter, centimeters, feet, inches. Okay, there are many examples, many types of measurement of length is available. So there may be different units of same physical quantity. Write these things. There may be different units of same physical quantity. There are different types of units available for same physical quantity. So to avoid confusion, all the scientists in the world have come together and they have decided to use some standard units. Okay, England was using other kind of system, France was using other kind of system, some other country in Africa was using other kind of system. So a lot of problem was created because of different type of units they are using. Okay, so to avoid all this problem, in our international physics or science community have decided that we will use a system of unit. We will use this system to measure the things. And the system of unit, in the system of unit, we have defined units of only 7 fundamental physical quantity. All others can be derived in terms of 7. They are called derived, which can be derived in fundamental, and the 7 physical quantity which cannot be derived in terms of other, they are called fundamental physical quantity. So units are reference in terms of which we can measure. How many types of units are available? There are many types of units are available. So one of the type of unit system of unit is SI system. SI system. This is the latest and most evolved system of unit. SI system is latest or most evolved system of unit. In SI system, this is internationally accepted system. The name of system is System D International. It is actually French language word, so it's System D International, something like that. Okay, I am not very good in French, so I do not able to pronounce it. I think it's like System D International. Okay, so SI system or International System of Unit is a special system which is defined, which is decided by all the science community that we will use this system. In this system, there are 7 fundamental or base quantity. 7 fundamental or base physical quantity. With help of this 7 base quantity, we can define all other quantities. They are called fundamental. In terms of fundamental, we can define other. So there are 7 fundamental quantity, and all other can be defined in terms of them. What are these 7 fundamental quantities in SI system? Now we'll talk about the 7 fundamental quantity in SI system. First is length. Unit of length is meter. The symbol is m, small m. Length. Then mass. Unit of mass is kilogram. The symbol is kg, small k, small g, kg. We all know these things, na? Then this third is time. second symbol is S, fourth is current, ampere, symbol is only A, fifth is temperature, Kelvin, symbol is only K. Ampere and Kelvin, these are in capital, okay, all other in small. Sixth, amount of substance, this is measured in mole, symbol is just MOL. And last physical quantity is luminous intensity. Luminous intensity, it is measured in candela, symbol is CD. So these are 7 physical quantities. If you know the 7 physical quantities, if you define these 7 physical quantities, all other physical quantities which we have defined in our science community, which science community have defined, they can be derived in terms of this. So these are called fundamental or base physical quantities. All other can be derived in terms of this. All other can be derived in terms of this. All other can be derived in terms of this. Besides this 7, there are 2 supplementary units also. 2 supplementary units also. One for plane angle, which is denoted by theta. We have used this, it is measured in terms of radian. And second complementary unit is solid angle. It is denoted by letter omega, small or capital. This is capital omega, this is small omega. And unit of radian is steradian. STRAD, steradian. These are complementary units. These 2 are dimensionless. They are dimensionless, but they have unit. These 2 are special physical quantity. They are dimensionless, but they have units. Okay. So there are total 7 plus 2. 7 plus 2, that is 9 units available in SI system. And all other physical quantities can be converted into these units. If we define proper units for this, all other can be measured. Okay. This is the SI system of unit. Beside SI system, previously there were different systems in convention. So France was using MKS system. England was using FPS system. In MKS system, the length, these systems have only 3 types of units. They have 3 types of unit. Unit of length, unit of mass, and unit of time. All science community before SI system was using only 3 types of unit. 3 unit, length, mass, and time. So length of unit of length in MKS system is meter. For mass, they were using kilogram. For time, they were using second. So SI system is just extended version of MKS system. FPS is used by British people. They were using foot or feet, then pound, and again second. Second was common in all the systems of unit. And last, CGS. This was also used in France. CGS. They were using centimeter, gram, and second as systems of unit. Okay. So these 3 systems were previous systems of unit, and we have derived a new system of unit based on MKS system. It is the extended version of MKS system, which is SI system. So we will use only SI system. Whole science community now uses only SI system of unit. Okay. We have defined units of other physical quantity in terms of SI systems. Okay. There is a table available within your gym book. If you observe your booklet, if you observe your material which is provided to you, in your gym book you will find a table. In that table, all different standard. What is it? Gym book is module. The reading material which we are providing here, that is called gym book. Okay. So in gym book, if you don't have gym book, then please make arrangement for it. It is very helpful for studies. Okay. There is some questions also available in gym book and theory also. So in gym book, you will find there is a table in which all the physical quantities which are required for us and their units and their dimensions is also available. So read that table. You will understand what are the physical quantities, what is their dimensions, what is their units. Okay, you will just read the table, you will know the formulas governing them also. Okay, so just go through that once. Clear? So sir, what is F in FPS? F is fit. Fit or foot? Fit or foot? Feet is standard, but some people also say this is foot. Better is fit. Okay. Okay. So these are the different systems of unit available to us. Now we have defined different units of the physical quantities. For defining unit, there should be some properties. There should be some properties of unit. It should be easily accessible to all. Everyone should be able to use it. It should be reproducible. Whenever you want to measure something, you should have the unit available so that you can compare and measure. Then it should be invariable with time. Suppose today 1 meter length is this, and after 10 years, suppose 1 meter length is this, then this will create a lot of problems. So it should be invariable with time. Okay, it should be reproducible, it should be transportable. That means when if you are using a unit in France, then you should also be able to use that in India also. It should be accessible everywhere. Okay, and it should be convenient in use. It should be convenient to use. Suppose you are defining a unit so large or so small that you are not able to use it, then how that is possible, how that is useful? So there are some attributes of properties of units. We cannot just define anything as unit. There should be some guideline. So these guidelines are: it should be accessible, it should be reproducible, it should be transferable, we should be able to transfer it, it should be convenient to use, and it should be invariable. It should not be changing with time. Okay, these are some attributes of units. We have covered what are the different types of units. Unit system. Now we will talk about types of units. Types of unit. We have discussed different systems of unit. Now we are discussing types of unit. If units of fundamental physical quantity is defined, they are called fundamental units. Fundamental. Units of fundamental physical quantities are called fundamental units. Units of fundamental physical quantities are called fundamental units. Okay. Then if you are deriving a physical quantity, then that unit is called derived unit. Fundamental units may be meter, time, second, etc. And derived unit is meter per second or Newton. SI unit of force, which is Newton. 1 Newton is 1 kilogram meter per second square. It is a derived unit. So there are some units which are derived from fundamental quantity. Okay. Then practical unit. Sometimes units are very small or very large to be used. Like suppose you are going to a goldsmith, you are buying some silver or gold earrings. Okay. To measure the weight of earring, they are usually very small. Okay. To measure the weight of earring, kilogram is very big unit. Then in that situation we are using grams. Okay. So there are some practical units also. For example, if you are measuring the distance between stars, then meter is a very small unit. Then there in those situations we are using parsec, parallactic second. Parallactic second, the name is parallactic second, but it is a unit of length, it is unit of distance. It is the largest unit of distance, parallactic second. And suppose you are measuring very small length, like dimension of a nucleus, then you need very small units. For that, fermimeter is used. Fermimeter, angstrom. To measure atomic distances, we use angstrom. To measure subatomic distances, we use fermimeter. So in different situations, we need different type of unit. Those are called practical unit, which are easy to use in those situations. Okay. Millimeter also is a practical unit. Yes, nanometer also is practical unit. So these are practical units. So fundamental, derived, practical. Then fourth type of unit, improper unit. Improper unit. Okay. A unit which is defined in terms of other physical quantity, that is called improper. For example, for weight or force, sometimes we are using kilogram. Whenever one asks you what is weight, you are replying in terms of kilogram. My mass is suppose 60 kilogram. My weight is 60 kilogram. So weight should be in force, na? Weight is like force. It should be measured in Newton. The proper unit of weight is Newton. But sometimes weight is given in terms of mass. The meaning of mass, the meaning of giving weight in mass is mass multiplied by g should be the weight. Mass multiplied by g should be the weight. So when you are saying of giving unit of a physical quantity in terms of different physical quantity, that unit, that kind of unit is called improper units. One more example is centimeter of Hg for pressure. Centimeter of Hg. Centimeter of Hg. Pressure can be sometimes given in terms of centimeter or mm of Hg. So you are using length to measure pressure. Length is a different unit, and length is different physical quantity. Pressure is a different physical quantity. Pressure is derived with help of length, mass and time. But you are using distance to measure pressure. So this is an improper unit. This kind of units are called improper units. Okay. So there are fundamental units, derived units, practical unit, improper unit. And there are also conventional unit. Conventional, for a long time we are using that kind of unit, so they are called conventional unit. For example, calorie is a conventional unit of heat. Okay, so we have discussed about the systems of units, what are fundamental, what are derived unit, what are different types of systems available. Okay, so because time is over, so I should stop now. In the next class we will cover the dimension portion of this chapter. Unit is very simple. Okay, today we have covered units. One or two points of unit is still left. We will cover that in next class. Okay, thank you all of you. I hope you are able to understand. Thank you. Take care.